Hello boys and girls, it's me, the Guide Knight, and welcome to part 9 of my Godot 2D platformer series about this small girl here with the funky, spiky hair. Maybe she's a relative of Son Goku, who knows. Last time we added our robot, and we can kill it and step on it, because we rotated the... what's that? Anyhow, we rotated the collision shape. Let's go here to the visible collision shapes. Let's see what happens. But there is actually a bug. If you keep hitting it, the robot goes up and up and up and up and up and up and up, which is something super weird and we would like to fix. But before we start fixing that, I would like to resave. I don't know. So basically, why this was happening, this window, is because right now we are already using the 3.3 stable official version, and previously we were using the 3.2.3 version. So go ahead, go to the Godot engine and download it. I did download the 64-bit standard version, and also you can read what's new under Godot engine /articles /Godot -3 -has -arrived, or just look what's new in Godot 3.3 in Google or any other search engine, and you will probably find this article. Basically, they announced long-term support for the branch, I guess. I guess the 3.2 has a long-term support, and it will receive updates. And 3.4 initially was renamed to 3.3. So I guess this is the recommendable upgrade for all users. As such, Godot 3.3 is fully compatible with Go 3.x, like you'd expect from a release named 3.2.4, and is recommended upgrade for all users. Yeah, so the long-term support, I guess, is, as they renamed the branch, the long-term support will be 3.x. And they did that because they added more features and not only bug fixes in the awaiting of Godot 4. And basically you can read all the differences that they did. Like they did add a web editor where you can have like a virtual keyboard and stuff like that, and also fixed some stuff like one-way collision fixes and whatnot. So overall, I advise you to download that and use it. After this small notice, I have another one thing. Maybe you noticed that things look a little bit different. Right now, I am actually using a 1440p monitor. So I'm probably gonna do 1440p videos from now on. Let me know if you can still see the stuff, or they're like maybe too small, or I should try to enlarge it somehow, maybe record in 1080p again. So after that, without further ado, let's go ahead and add some logic to our robot, right? So go to the enemy here on the left and open the robot GD script. And maybe open the scene as well. Like we have the robot scene and the robot GD. So first thing we wanted to fix is like this weird stuff, right? Like I could simply go to the script and make sure we don't do this. Like I guess this is what's causing it, right? If I comment it out, it's not gonna happen anymore. Yeah. Yeah, and I also added this already. Anyhow, so this is what's causing it. But I don't want to have it. I mean, I don't want to fix that, because I actually would like the player to be able to pass through the dead robot, because otherwise it may be super weird when we have like larger robots, because I think we're gonna add positional changes, I mean size changes to the robots. So I would like the player to be able to pass through this and not just be hindered by the robot. So in order for us to do that, you already saw I added the set collision layer too. What does that mean? Like if you click on your robot here in the scene, for some reason I cannot make this bigger, but I'm clicking on the robot here. On the right side, there is this collision and there is layer and there is mask. And this basically sets the robot layer to 2. But if I do that, let me just edit, set like quickly here manually. If I do that, I can still collide with the layer of the robot. Why is that? Even though the robot is on layer 2 and my player, let me open my player script, player scene, and my player is on layer 1. The answer is actually if you hover over the layer, you see this really informative window saying that, let me read you about the contact, like the second paragraph or the third paragraph. A contact is detected if object A is in any of the layers that object D scans, or object B is any of the layers scanned by object A. What does that mean? Like our player is object A and our robot is object B. So our player scans for collisions in layer 1, right? So in that case, the robot is layer 1. If we move it to layer 2, our player will still scan for layer 1 collisions because of the mask, and the robot is not there. The robot is in layer 2. So the player says, okay, I don't have a contact. But there is another thing. Look again. It says also, or object B is any layer scanned by object A. So like this means that the inverse logic also applies. Like the robot scans for collisions in layer 1 and our player still happens to be in layer 1. So if I move our player to layer 2 right now, so they are both in layer 2, but the mask is layer 1, they can pass through each other, right? Because they're both scanning for collisions in layer 1. They're both scanning collisions in layer 1, but they are both in layer 2. So basically, how I can fix that is I can make our player in layer 2 or any other layer than layer 1. And I can then just set via the script this set collision layer. It is, I cannot make this bigger for some reason. I have to check out how to, sorry. Okay, I guess the stable version is not as stable as I hoped. But in the meantime, I found out that in the editor settings here under editor, you can make the display scale. And I made it 125 just in case it's not really visible for you or too small. If you don't have larger monitors. So maybe you can comment on that. Tell me, what do you prefer? Should I keep it as it was originally in the first part of the video, or should I just make it scaled to 125 or 150%? So I expect comments there, guys. All right, so basically let's go back to what I was saying here in the set collision layer. The set collision layer is nothing different than what I already showed you. So where is it? Actually, basically it's the collision layer. It has a setter and getter, and the physics layers are in this area. This area is in. So in other words, this is nothing different than just this layer, right? We are setting it programmatically. So let me disable the collision shapes again and see, okay, if I kill the robot now, I'm changing the layer, and as our player right now is in a different layer, we should be able to pass, right? And I don't really care about that the player is behind the robot. I mean, we can make it in front as well. Maybe we can make it in front. So that's a really easy change. We can go to our world TSCN and move the robot behind the player. We can do that, I guess, from the, yeah. So now, right now our player is in front of the robot. So now that we have figured that out, let's actually continue with adding the script or changing the script to our robot, right? So what we wanted to do is we wanted to make some actions, right? So let's create an enumeration, and I'm gonna go with idle, run, fall, and dead. Like those are the 4 options I would like the robot to have. And let's add in the 2D scene, let's see what we have. We have idle and dead. So we need to add more animations. Like I clicked on the animation sprite, clicked on a new animation here with this button, and I'm gonna go with fall and also the run, right? So let's go ahead and open our enemy assets and see if we have the jump. Maybe the jump animation is what we need, but let's first define the run animation. It's probably straightforward to do. And let's play it here. A little bit too slow again. Let's make it 10 frames per second. Maybe 15. Yeah, let's make it urgent, or maybe, okay, 12 frames per second. Stop playing and click on the faux animation. And let's just add all the jump animations here and pick something from it. Like, then we can play it. But we need to play the faux animation. Like, okay, so I'll probably go with, I don't know, maybe the first, because it's actually jumping over something and I don't want to like have this, right? So the landing part I'm going to delete and the jumping part. So I'll just keep it in the limbo for that matter. Like if I do 10 frames per second, no, that's too fast. Like let's try 7. Yeah, let's say our robot just constantly falls and is in a state of urgency there. So now that we have defined our animations, we can go back to the script and we have our enumeration. Let's move the enumeration. Where do we move it? We move it below the constant or maybe above the constant. Okay, and then we need to define speed, right? The speed for the robot. We want the speed to be less than the speed of the player because we want the player to be able to outrun our robot, I guess. So 200 is what I'm going to use. I'm going to add another variable. It's called direction. This is the direction the robot is moving towards. Like minus is left, 0 is just staying in place, and 1 is going right. This is how I want to do it. And I'm going to define a state. And I'm going to, the initial state is going to be idle. Like the robot is not going to move anywhere. So let's see what we have here, right? We have the velocity, the speed, the direction. So we need to add this to our, so let me explain first how I want to do it. Like I would like, yeah, let's go to the idle animation for the default. Okay, so I would like to have a timer here that runs every n seconds that we define, maybe 3, 4, 5 seconds. And after this timer runs out, there is a random function that we just pick the next state, right? So we'd like to pick the next state the robot is in. And also it's gonna be also random. So let's go ahead and add that, like add child node and add a timer, like a timer. And I'm gonna call it an action timer. This action timer, we are going to connect to our robot script. So go ahead and click on the node on the right side and connect the timeout function, or the timeout signal rather, to the robot script and call it on action timer timeout. All right, so we have now our timer timeout here. And what do we want to do in this time? Like we would like to act, right? We would like our robot to act. We're going to create an act function. And also we would like to reinitialize the timer, right? So in order for us to do that, I actually need the variable of the timer inside the script. So if you remember already how we can do this, we can just get the action timer with the $sign, like action timer. Right now, and I'm also not forgetting to write the onReady function, variable, keyword, sorry about that. So action timer, and how do I reinitialize the timer, right? I can just do start. And I'm going to say, I would like to have a random interval, like I would like to have a random action interval. I don't want the robot to change its action framework on every 3 seconds, for instance. I would like to have a range. So I'm going to use the run range function. And for this, I'm going to say, okay, from 0.2 seconds to 3 seconds. This random range just returns a random value, floating point value, between the from and to. So anywhere between 0.2 seconds or 200 milliseconds to 3 seconds. And this is going to start the timer again, then this is going to call this function again and initialize it once more. So it's a loop, so to say, with a timer. Okay, so let's define our function called act, right? And what do we want to do in this act function? Like, we would like to change the state, right? We would like to change the state. Okay, so let's say if the state is equal to fall or the state is equal to dead, then what do? We don't change the state, right? We don't want the robot to start running when the robot is dead, or the robot to start running in the middle of the fall, right? So let them fall down or let them die in peace and stay dead. So we're going to define here a random variable that we're going to use for our actions. And we're also going to use the random range again, right? And we're going to say from 0 to 1. We want to have a variable that's from 0 to 1. And if random is less than 0.3, then we'll say direction is equal to 0. Like we are idling around. The robot is idling around. Else if random is less than 0.7, then direction is equal -1, or else direction equals 1, right? So in this case, we're running left. In this case, we're running right. So 0.3, 30% chance of staying in place, like 40% chance of running left, and 30% chance of running right. So that doesn't seem right. So let's make it 35% chance, maybe 40% chance of staying in place, and 30% chance for each. So that should be a little bit more natural. We don't want the robot to run too much left, right? So we're only changing the direction here and not affecting the state in any way. So we need to act on the state, right? So how do we do that? In the physics process, we are doing some velocity changes. And maybe this is the place we would like to also move our robot according to the direction the robot is moving towards, right? So let's see. First of all, we can check the state. If state equals dead, the robot doesn't move, right? Return. We don't do anything. Like if we're dead, we're dead. Or if they are dead. Like the robots. Don't listen to me, Skynet. All right. And what do we also want to do? And maybe we can just also say like velocity x equals 0. Because we don't want to move in any direction if we had previous velocity. Maybe this is not needed, actually. So let me just try with the return first and see how it behaves. So if the direction is not 0, then we can say velocity x equals direction times speed, right? So minus is left and the speed is 200. So minus 200 or 200. It's linear, like it's either 0 or 200, so to say, in any direction. And then we move, right? If you remember, the move can be done with move and glide, move and slide, and so on. We're going to use move and slide. We're going to add the velocity here. And we are going to... Actually, that's not... that doesn't make any sense. We already have it. Never mind. Okay, what do we have here? Okay, so right now we are... What will happen if we run the game right now? You change the... Yeah, let's try to see what happens, right? What do you expect to happen? Did something happen? Okay, let me maybe print here in each act, like print. Oh, I know. Acting. And then maybe here I can print the direction, right? Direction. And let's see. Ah yeah, we forgot one minor detail, and that is to start the timer first, right? Auto start. We're just basically adding the timer but didn't start. So let's try again. Okay, acting direction 0. Direction 1, okay, moved. But if you see, it doesn't change its animation, right? It's idling. Maybe we can change the seed of our level generator so that we can have a little bit different level. So I'm going to open the simple dynamic level and change the seed. Something that's maybe easier for us to see. Okay. Yeah, should move right at one point. Come on. Come on. Yes, moved right. Okay, but let's go back to our robot and change its animation. So we can do that actually in the physics process. Like we can say animate, or just animate. Let me see, animate is okay, it's not a predefined function. We can just define the function called animate. And we are going to change the animation. So let's do that. And we can say like with the match statement. And if it's basically we're matching on the state is an enumeration. We have those 4. So if the robot is dead, we want to have the animated sprite play the dead animation, right? We already have that, but and then return, because otherwise we're gonna fall towards other stuff. And we don't want to change the state or anything when we're dead, when the robot is dead. So if the state is falling, like, then animate fall. In this time we don't return, because after the fall there may be a state change. If the state is idle, we're gonna animate idle. And if the state is run, we're gonna animate run. Actually, there is the normal way a state machine, basically state machine works, is in each state you have a predefined set of states you can migrate towards. So actually what we did here in the player as well, with the states, that's not really a state machine. We're gonna refactor that later on, but for now let's just keep things simple and do the same here. I have already this refactored in my GitHub page. You can download it and see how it looks. But we're gonna keep this thing here simple for now. So let's first check if we need to flip the sprite, right? If velocity x less than 0.1, let's say a small number, maybe 0.1, and velocity y equals 0, then we can say animated sprite flip h equals true. And then else if the other state, like greater than 0, greater than 0.1 and velocity y equals 0, then animated sprite equals false. Why do we need the velocity y? This is from my sample project. Let's see. I'm gonna just remove it and just flip on the x velocity, and probably my past self is gonna scold me because I maybe had something in mind, maybe I didn't, I don't know. Anyhow, if velocity x equals 0 and velocity y equals 0 as well, or maybe let's go with 0, then state is equal idle. Like here we are actually changing the state. Like if the robot is not moving, then we are idling. Else if velocity y is not 0, then we can see state equals fall, right? And then else if velocity x not 0, again not 0. Then state, you guessed it, equals run. So maybe this is enough to have some animation on the robot. Let's see. Come on. Yeah, I need to change that. I'm gonna make it act more. Yeah, it is rotating, but once it actually stops, it flips. It's... Why is it flipping? Okay, if this is less than 0, it's flipping to... Maybe in that case it is actually... Let me print here the velocity. And I'm going to remove the print from the acting and the direction. And maybe I can now see, okay. Okay, let me see what happens here. It has 200, so it is greater than 0. It's greater than 0. The flip is false. Okay. And then it is suddenly 0. Do I have any? I think I'm gonna actually remove this play idle, and I'm gonna just do state equals idle. I'm gonna also remove this thing from here, because why not? Okay, do I have played that? Okay, I'm also gonna remove this and just say state was that. All right. Why does it flip itself? It shouldn't. It's 0. And 0 is not less than 0.1. Ah, crash. This is less than 0.1. I forgot to add the minus. So yeah. So if it is less than 0, okay. Yeah. All right, so we want the flip to be only when we are looking left, right? And we are looking left only when we are moving left. And we are moving left only if the velocity x is less than 0. So I forgot the minus here, basically. So this should not flip the robot once it hits the wall. Yep. Looks nice. So I guess that's it for this episode, guys. I'm going to go back here and change this to 3 seconds. I hope you did enjoy it. And if you have any questions, don't hesitate to ask me. In the next episode, we are most likely going to add an enemy generator so that when we run along, we actually can see more enemies, right? Because right now we have only one manual robot. And this thing is a little bit too annoying, so I am going to change that as well. You're wondering what I mean? I mean the dynamic generator, the batch size. I'm gonna make the batch size 30. I don't want to see it like flicker on my back. I was talking about the stop batch basically. So if I go back, yep, now it's a little bit larger, the level that we are generating, and we don't see the annoying stop batch. So that's it, guys, from me. Thank you very much for watching, and yeah, if you have any questions, don't hesitate to ask me, as I mentioned, and stay safe, stay cool, as I know you are, and see you next time. Bye bye.